Now we'll work an regression example, and to do that we'll start with the test for a linear correlation. A homeowner randomly selected 10 days and recorded the amount of electricity in kilowatt hours consumed in his house along with the number of hours he ran his air conditioner. So the X values are the hours he ran the air conditioner. The Y values are how much electricity he consumed. His objective was to test the claim that a linear correlation exists between the number of hours of air conditioner usage and the consumption of electricity. So first, let's use the sample data below and a 0.01 significance level to test his claim. Now we'll start by looking at a scatter plot. Now I've already entered the data in our list 1 and list 2. So you can see, let's go up. My values start with 1.5 air conditioner hours and a 35 kilowatt hour usage. Okay, so I've already entered the data just to save a little bit of time. And so now we want to plot, and recall that we use this stat plot here, so second stat plot, and then enter twice. It turns it on. Tab down to the scatter plot, make sure that's selected. Choose our list 1 and list 2, and so they're already set at L1 and L2, and choose our mark. Okay, now we will go to zoom and choose 9, the function 9 zoom stat. Okay, so it appears that there's a bit of a positive linear correlation here. It's not a perfect line, but it does tend to show us that as our X values, air conditioner usage hours, increases, the Y values, the kilowatt hour consumption, increases. So now we'll run our hypothesis test. Let's see what information we had. We had an alpha of 0.01, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sets of ordered pairs. So our sample size is 10. Right, so our null hypothesis is always that rho, the linear correlation coefficient, is 0, no linear correlation. H1, rho is not 0. We'll find our critical value, test statistic, our p-value, and make a decision. So we'll find our critical value using the R table. We have a two-tailed test, an alpha of 0.01, and our n was 10. So let's see, 10 and 0.01, we get over here the 0.765, and so it'll be plus or minus 0.765 for our two-tailed test. So R is equal to plus or minus 0.765, 0.765. Okay, and let's start our diagram down here. Here's 0, no linear correlation. 1 is our perfect positive linear correlation. -1 is our perfect negative linear correlation. And we suspect it's a positive correlation because the slope of the line was going up. Okay, so at 0.765 and negative 0.765, let's mark that. Here's negative 0.765 and positive 0.765. And we'll get a little shading in here to show our critical region. Okay, Now we need to find our test statistic and our p-value. So we'll go to Stat, Test, and we'll tab down to the Linear Regression t-test. And there it is. Okay, my x values are in list 1. I would change that if they were somewhere else, so keep that in mind. You may have them somewhere else than what's initiated here. My y, list 2, frequency is always 1. It's always a two-tailed test. We don't need to enter anything in this field, and then we'll calculate. Okay, so our p-value to 4 decimal places is 0.0015, and that 4 says we truncate, so 0.0015. Tab down to find r. 0.85662, so 0.857. Okay, so our test statistic was 0.857, and our p-value was 0.0015. So let's put the test statistic on the graph. 0.857 would be somewhere right in here. Okay, let's get that. Okay, 0.857. So our test statistic is in the critical region. Our p-value is less than alpha, 0.01, 0.0015, that's less than alpha. So our decision then is to reject the null hypothesis. So if we reject the null hypothesis, we will conclude that there is sufficient evidence to support the claim that a linear correlation exists between air conditioner usage and the consumption of electricity. Between air conditioner usage and the consumption of electricity. Okay, so we have concluded that there is a linear correlation, and it's a positive one. Now, we want to find out what the proportion of the variation in electricity consumed is explained by the linear correlation between air conditioner usage and consumption of electricity. It's not 100% affecting the consumption of electricity, but there is a certain proportion that is causing that. So where do we get that? Recall that's R squared. So back to our calculator, let's find R squared. There it is, 0.7338. So let's see, we'll write that to 3 decimal places, 0.734. And then we can also write that as a percent. 73.4% of the variation in electricity consumed is explained by this linear correlation between air conditioner usage and the consumption of electricity. And of course there are other reasons that the consumption of electricity is changing, and that would have something to do with perhaps some of the other energy users in the home. But air conditioner usage is a huge contributor to the change in electricity consumption. Okay, so now getting into the regression part, let's write the regression equation. So recall it's y hat, and then on the calculator we said we're going to have this a plus bx. So we'll look at the calculator and see how to fill this in. Okay, so we have been given a, it's 30.504. Now each problem will have different rounding directions. So in this one we'll round to 1 decimal place, or let's round to 2 decimal places. That's what we'll do. 2 decimal places for A and B. So here's A, here's B. A is 30.50, B is 5.56. Okay. And now we want to find the best predicted electricity consumption for a day when the air conditioner ran for 10 hours. Okay, so remember X is the air conditioner usage, and Y we're predicting is how much kilowatt hours, how many kilowatt hours we consumed, or the homeowner consumed. So we have to decide at this point now, are we going to use the equation, or are we going to use just average kilowatt hours for this household? Well, we have determined that there is a linear correlation between these two variables. Once we determine that, then we can use the equation. So we will use the equation y hat is equal to 30.50 plus 5.56, and we'll input 10 for our x. And we get 86, that's a decimal there, 86.1. So our best predicted electricity consumption for a day when the air conditioner ran for 10 hours is 86.1 kilowatt hours. So there's a complete correlation test and regression analysis.